Hi everyone, this is Akshay from EC department. Today we are discussing about nodal analysis in network analysis. In network analysis, nodal analysis is the main thing, and we want to study nodal analysis for analyzing the circuits. Nodal analysis of sinusoidal response. Introduction to nodal analysis. Nodal analysis is a systematic method for analyzing electrical circuits. It focuses on determining the voltage at each node relative to the reference node. It is a technique simplifies circuits analysis, especially in complex networks. Basic concepts of sinusoidal signal. Sinusoidal signal or periodic waveforms characterized by their amplitude, frequency, and phase difference. They are fundamental in analyzing AC circuits, such since most AC sources are sinusoidal. Understanding these signals is essential for applying nodal analysis effectively. Importance of phasors in nodal analysis. Phasors convert sinusoidal signal into complex number of easier and easier manipulation. The representation simplifies the calculation by converting differential equations into algebraic ones. Using phasor allows for the analysis of circuits in frequency domain. Setting up nodal analysis equations. To perform nodal analysis, identify all nodes in the circuit and select a reference node. Write Kirchhoff current law KCL equation for each node, excluding the reference node. Each nodal analysis represent each equation will express the sum of currents leaving at a node equals to 0. Node is also known as junction point of currents. The sum of the currents coming to the junction is equals to the sum of the currents going to the junction. The algebraic sum represents direction also. The algebraic sum of the currents is equals to 0. This is known as nodal analysis. Incorporations are sinusoidal sources. Sinusoidal voltage source can be represented as phasor in nodal equation. Current source can also be converted into phasor from the constancy. This ensures that all elements in the circuit can be same domain, phasor domain. Solving nodal equations. The resulting nodal equations from the linear system that can be solved using matrix methods. Techniques such as Gauss elimination method and matrix inverse can be employed. The solution held in phasor voltages at each node, which can be converted back to time domain. Analyzing circuit responses. As once node voltage are determined, the current through each component can be calculated. The sinusoidal response of the circuit can be examined by the converting back to the domain. This relieves how the circuit behaves over time, including transient and steady state responses. Advantages and limitations. The primary advantage of nodal analysis is systematic approach to circuit analysis. It can be held at variety of circuit elements and configurations effectively. How it may become from every large circuit with many nodes. Advantages and limitations. Nodal analysis can be used to mainly to analyze the circuit, to analyze the complex circuit to easier circuit, and analyze the currents and voltages at any point. Point is also known as node. Node is a junction of currents. The number of currents coming to the node is equals to the number of currents leaving to the node. This is known as Kirchhoff law. This is also known as nodal analysis. Nodal analysis is the combination of Kirchhoff laws and Ohm's law. Ohm's law is known as V is equals to IR. Conclusion and further study. Nodal analysis is a powerful tool for analyzing sinusoidal response in electrical circuits. Mystery of technique paves the way for advanced studies in electrical engineering. Further exploration into related topics like mesh analysis enhance the circuit understanding. Mesh analysis is also known as one type of nodal analysis. Mesh analysis is a loop analysis. In mesh analysis, we find out the loops and we find out the currents. In nodal analysis, we find out the nodes and we find out the node voltages. The presentation provides the structured overview of nodal analysis in sinusoidal response with a balanced approach of both fundamental and other views. Thank you. Thank you to all. This is the explanation about nodal analysis in sinusoidal response.